Welcome everyone to today's webinar. The webinar is about new features in Datamine's stratigraphic modeling package called Strat3D. And the new features are the ones that came with version 2.1. That version was released in January. So we'll cover a few of the new features. Before I start, just a little bit about myself. I'm a geologist. I've been working for the company for 12 years. Before that, I worked for Goldfields in the gold mining industry. Yeah, so I have almost 20 years experience as a geologist. My current role in the company is I am the solution owner of all the resource modeling software that Datamine develop and sell. So that includes Datamine Studio and then also Strat3D. And there's going to be a few new products also in the near future, hopefully. Yeah, but today we will stay focused just on Strat3D and just the new features that were released in version 2.1. For those of you who haven't seen Strat3D before, please get in contact with me. I'm going to share my email address at the end of this session, and I would like to show you maybe using a personal web conference. We could go through what the software can do. Okay, so without further ado, let's start with the new features. This presentation is going to be about an hour, so I'll try to be as quick as possible. Let me just get everything ready. Okay. So this is what we're going to cover. First of all, just a very brief introduction to Strat3D. Then we will look at the improved LAS file import. We will look at the new 2D fence diagrams and the improved correlation tool. We will look at the new ways of modeling of intrusives in Strat3D. And we will also look at the new coal washability feature. That's basically our first version of the coal washability development that we are planning for Strat3D. So for those of you who are not familiar with Datamine, we have a whole range of software from geological data management for exploration data right through to mine planning, mine scheduling software, optimization software. So there's a full complete suite of software that covers the mine planning cycle. And today we're focusing on stratified modeling and maybe specifically on coal modeling because we're looking at washability. But Strat3D is also very well used outside of the coal industry for other stratified ore bodies. So just a couple of advantages of using Strat3D. Strat3D is based on logical geological principles, and throughout the application you can use those principles. So it's principles of geological age, principles of relationship between different strata and the relationship between faults, different faults. Yeah, there's a whole host of geological principles that's used by the software in order to build the models. Strat3D is very easy to master. we have had geologists who were able to produce their own models within 1 day of training, and even some geologists even trained themselves to be able to produce a model in a couple of hours. So it's definitely a very easy application, and you'll see it is due to the workflow that we have in the software that it's so easy and logical to use. It's also very powerful and very quick. It's got a very powerful modeling engine that can do all sorts of faulting, including reverse faulting, and it produces these models in a very short period of time. Also, the way that we handle data and the way that we handle the settings that you use when you do the modeling makes the whole process very auditable and repeatable. The data is stored in a very logical way, and all settings that you use are also stored in the application, and it also produces a number of log files to report all the progress that you make. Also, the software comes with a powerful graphics engine that makes the visualization of your data and also then the auditing of the data and the models a pleasure. And then also finally, something where we've had some good success with Strat3D is its easy integration with mine planning software. In that sense, we have been able to give some unique solutions to clients which they were not able to do previously with other software. So basically, in short, how does it work? You give the software your drill hole data. You can also give it survey data, and then you give it the structures, the geological structures. You define which seams or which strata you want to model, and then basically the software will go off and produce wireframe envelopes. It will also produce strings, all sorts of different strings like split strings, extend strings, and it will also do contours. And then basically it will go and fill those closed wireframe envelopes of the various seams that you model. It will fill them with model cells to produce what is called a block model. And this block model that we produce is slightly different from the traditional block model that Datamine has been producing for a number of years, in the sense that these blocks are not completely square. If you look at it from the side, the top surface and bottom surface fits the seam very closely. And once you have a block, you can do various things with that, including modeling, and that block model can contain a lot of information, and that kind of also distinguishes us from the more traditional grid modeling software that is that's more commonly used in this space, because we store all information in one file, in one block model. Okay, so that's basically what a block model looks like of one of the seams. You can see it's colored by ash content, and you can then basically visualize anything that is that block model. And as I said, we use a new type of block model. So the blocks that we produce in this block model is not completely square. The top and bottom surface conforms very closely to the top and bottom surface of the seam. And then if you take a slice through that block model, here's a slice showing various seams and also some intrusives, the orange The orange in here are the intrusives, and the red area below is basically the basement, and then the blue, green, and yellow are the various seams, and the red then there is the oxidized or weathered zone. And then if you open this block model in the table editor, you'll see it looks very much like an Excel spreadsheet. One big table that contains a lot of information. And some of these tables could have like over 200 different columns with information in it. Okay, new features in version 2.1, and so that was basically the brief introduction to Strat3D. If you want to know more about Strat3D itself, please don't hesitate to contact me. The rest of the presentation, I'm going to assume you already know something about Strat3D. So basically, in this version, we already had in previous versions, we had last file import, but for those of you who tried it, you would have noticed that it only supported last format 2 and also only some last format 2 files. So we did quite a bit of work in this version to be able to support the last 2 and 3 formats as they are defined by the geological authorities or so I'm not sure if we support any format 2, any format 3 file. We still try to keep to the conventions that are prescribed, but I would be curious to get your feedback on that. For those of you who are not familiar with LAS files, LAS files basically contain some geophysical data and that's recorded by a geophysical instrument, and it's these little squiggly lines that you see in the correlation plots. That's basically showing the geophysical properties that was captured by that instrument. So there's a lot of information in there, and typically these files have a big header section, and so you need specific software to understand these files. What makes our LAS file imports quite unique is that we can do batch import of LAS data, so it's not one file at a time. You point it to a folder and then you import your LAS data. Okay, the second area of enhancement that we also focused on in version 2.1 was the correlation plots. We extended that functionality to become kind of like a 2D fence diagram functionality. So in order to do that, we allow now for scaled horizontal offsets between drill holes. So you can view it in a conventional way, but you can also view the scaled horizontal offset. And you can switch between these modes. You can save the hole selections, the holes that you use the correlation plot, and we can save multiple lists of holes. You can also now print the correlation plot. It is basically just a print screen of what you see on the screen, and we're hoping to extend that functionality also in the future version. But I'll tell you a little bit more about that later. Also, something that was asked for is the ability to record any changes that you make in terms of your correlation, to record that in an audit log. So if you make a change in terms of depth that you change, or also if you reinterpret your seam interpretations, all of that is now saved in an audit log. And this is just an example of what a print looks like. you can see in this print there is a scaled offset between the different holes that was used to produce this fence diagram. Another area that is very powerful and can be very powerful, and I think it distinguishes us from most of our competitors in this space, is the way that we now allow for the modeling of dikes. Basically, this functionality allows you to go and create complex shapes using or complex volumes using the CAD tools functionality that came into Strat3D in the previous version. And those complex volumes can be created using conventional wireframing functionality. And these complex volumes can then be incorporated in the strata modeling process. And so in this case, you can see we associated in this stratigraphic sequence, we associated the dike spotting. We associated it to a wireframe file, a Dykes TR-DM file, and basically this file is then also used in producing the stratigraphic model. And in the picture on the right, you can see that's what it looks like if we model two dikes. The dikes are the ones in red. So there's actually a lot of things that you can do with this functionality. You can model mined out areas, and any complex volume can be included now in your stratigraphic model. Also, what came out in this version was our washability functionality, or the first version of it. And this is not we're going to stop it. We're going to keep on enhancing this functionality. But at least in this version, we have included our first version of washability, and with this, we aim to do the basics of washability. So if we look at this little diagram on the right-hand side, basically you do your raw quality estimation first, then you wash samples using the new input functionality. It does a bit of validation of that data, and then you would go and regularize your wash samples, and that is to cater for situations where you have wash data that was analyzed at different densities. So the regularization step is to make all of the densities in the data set the same. And then you would do your compositing. The compositing would be done using the modeled seams, and it will also then weight it according to some raw coal quality weighting. So it will be based on the RG of the raw quality. Once you have your composited regularized results, you can then proceed to do the product analysis, and we have a separate window for that. And with the product analysis, in this version of the software, you can do a primary and a middling product, or just one of the two. You can just do a primary product if you just want to do a primary product. And then you can go ahead and then using that results, you can go and estimate into your block model. Now, in future versions, we hope to extend especially the estimation functionality to make it a lot more flexible. We have various ideas of how we are going to achieve it and how we can distinguish ourselves from our competitors in this space. Also, something else that we hope to do in future versions is to make more of a link between the washability samples, the product samples, and the raw quality samples, so that there is cross-validation between these various samples or various types of samples, because all of them relate actually to the same thing. They are all interrelated, and we shouldn't deal with them in silos. So basically, the screens that I mentioned previously. This is the import screen. We've got a flexible import mechanism. Also, it does some basic validation during the import step. This is the regularization screen. We allow for two types of curve fitting. It's a linear spline or a monotone cubic spline. And we also show the resulting tables, but we also show graphs of the data so we quickly can see if there are any issues in the data. Then in terms of the compositing, as I already said, we composite the data based on the modeled seams, and then we also weight them by the raw, by a field in the raw quality data. And you can select what that field should be. Normally that will be your RG field. Then in the last step, before you do your interpolation of the results in the model, you would do your product analysis, and as I already mentioned, you can do primary product as well as a secondary product, and the secondary product can be of a different coal quality, different from the primary product. Okay, and if you have any questions, please send your questions to my email address, and I will also send the questions with the answers to the whole group of people who registered for this webinar. I'm going to now just briefly show you some of this functionality in the software, and let me just see how we're doing for time. Okay, so we've got about little less than 40 minutes left. Okay, just bear with me a second. Okay, let's fire up the software. Okay, if you forgive me, I'm quickly going to build a new project from scratch. I cheated a little bit, and I'll point out where I cheated. So I'm going to create a new project. So normally the first step is you will import your draw data, and that's what I'm going to do now. I'm going to try to do this as quickly as possible because I don't want to bore you. So first we bring in our color data. And in this case, I don't have any survey data. I do have pathology data, so I'm going to bring in my pathology data. And this is all in CSV files. You can, of course, bring this data from a data or from various other data sources. I've got coal quality data, although we're probably not going to use it in this demo, but I'll bring it in nonetheless. And this is raw coal quality data. and then my strata data in this case is in a separate file, but you have various options for bringing in your scene definitions. But in this file we have separate a separate file with these definitions. Okay, so basically we have enough information now to go and build our drawers. But before I go and build the drawers, I've created 3 files with LAS data in it. And I've basically used somebody else's LAS data and just modified it slightly to fit the drawers that I use in this project. It's quite a challenge for us to get hold of LAS data, and that's why I encourage you guys to get back to me with your experience of the new LAS import. I would like to know whether it does work for you and how well it works. Okay, in this case, I have them in a folder called LAS, and there are only 3 files in that folder, but as I said to you, if you have 10 files or 100 files in that folder, and if they are the same format, you can bring them all in at once. Okay, and so in this case, it just asks me what field is the drawer ID field and what field is the depth field. And then I can select also here what geophysical properties I want to bring in. I'm just going to select all of them and say convert. And you can see that that 0 of these files have failed. So it looks like it was a success. And it basically produces 3 DM files each with its own LAS data. Okay, the next step is I can now go and build my drill holes. And in that same step, it also validated the holes. You can see there are some warnings for the qualities. I'm not going to worry about those warnings because they are related to gaps in the data. So we've got our drill hole data. That's normally the first step that you start when you start a modeling project. The next step is you will define your seams that you want to model, and that's what we're going to do now. So I'm going to define these seams from the codes in the drill holes that I just imported. And Strat3D will try to get this the stratigraphic sequence correct based on what is in the drill holes, but it doesn't always get it 100% correct. So in this case, seam B is not below seam BC. It's actually a parent of seam B1, B2, B3. So I'm just going to get rid of it and create it as a parent, and I'm going to rename it as seam B. And for better display, I'm going to color it as something else. And then for my topography, I already have a topo file, so I'm just going to associate it to that wireframe, and it's called topo.tr. And so it's going to use that topography file in the modeling process. Okay, I've got enough information in here now to save changes. In the last, when we do the, when I show you the modeling of the intrusives, we'll get back to the stratigraphic sequence and we'll change it slightly to bring in a dike as well into the model. Okay, so we'll proceed to the next step, and that is basically where we bring in our structure information, if you have structure information. And also, you can, in Strat3D, define your own structures based on your contours, etc., that the modeling produces. So you don't need to start off with structure. It'll be an interactive process. In this case, I already have some fault information, so I'm going to import that. And it's a datamine string file. You could see that there are various drivers there for bringing in data from other data sources. But for Strat3D to understand the data as faults, it needs to have certain specific fields in it, and in this case we do have these fields in there. So there's a throw field in there, there's a dip field. So you can see Strat3D is automatically based on on the information that was in that string file, it was able to go and produce these dynamic wireframes. And it's also colored. It's colored them according to different colors. And also, these faults already have some relationships with each other. So, for instance, fault F4, you can see that it starts on fault F3. So that information was also in the string file. I can point out while I am in here a minor enhancement that goes a long way in this version of Strat3D is that if we select a row in this table, it will highlight the point on the string. And that's quite useful when you want to change your throws or the dips along that string, because you can see then exactly where that point is on the string. And vice versa, you can also select on the string and it will select the same row on the appropriate row in the table. And you can see it selected with that yellow cross. I hope you can see it on your screen. It makes a yellow cross on the string. Okay. There are many other things that I can show in this fault section, but I'm not. This is not part of the scope of this webinar, so I'm not going to dwell any more on this. Okay, I'm going to jump straight to the correlation section, because that is where where some of the new enhancements in version 2.1 is. You will recall I mentioned that we extended the correlation tool to become now a 2D Venn diagram tool, and I'll quickly show you that. So the first thing that we did is you can now save your whole selections as lists, and I've already saved some lists. So this is one of the areas where I cheated. I already brought in these lists in this project when I created it. So if we, for instance, look at list 1, we can look at the correlation view of that and see. Okay, let's just look at the scenes only. There's the correlation view as you could have seen it also in previous versions. And now if you hit spacebar, you can see a scaled offset between these holes. If you hold the shift key and if you roll your mouse wheel, it will change that scaled offset view. And the functionality as you had it before is still there, so you can basically go and center your view on a seam if you wanted to center on a seam, or if you wanted to center your view on a specific depth, you could do that, or if you wanted to do it on a specific elevation, you can do that. You can still do your seam interpretations or your depth correction. You can do it in this view. As I also said before, you can now go and print your print this view. So if you right click and say print preview, and it will go and print it. And you can see this one, due to the page size that I had selected, it will go and print it on 3 pages. And then the last thing that we have in here is the ability to save all these changes to a log. Okay, if you want to go back to the normal correlation view, you can just hit the spacebar again and go back again. Similar to the old version, you can save various templates of what data you want to see. So let's say we want to see that that last data that I brought in earlier, and it's not very impressive, I admit it was. I only had last data for 3 holes, so let's quickly go and have a look at that. And you'll see I highlighted all these holes that are in yellow. Those are the holes that appear in this list. As we go and view them, you can see there's also a fault in one of these holes. Fault, and that is interesting. Let's see, where is my flash data? Okay, I see my coal qualities. Oh, there's the last data. It was just a bit higher up. You can see the last data only covers the top portion of the draw. So I said it wasn't very impressive. It's only built in a little bit of last data. But you get the idea. So if you had last data for all of these holes, you could have seen that using this template. And I'm not going to go into setting up these templates, but for those of you who know Strat3D, it is fairly simple to set up these templates. Okay, let's go on to the next area, and what I'm going to do now is I'm going to skip right over to the modeling step, and in here I'm going to produce a model quickly, and I've got some holes that I want to exclude from the model, so I just want to quickly define them. I have them in a CSV file. So I'm going to use that CSV file. And okay, so what we're doing now is we're basically building a wireframe model. It's not just building the wireframe model. It produces, in the same step, it produces contours for the roof and floor of each scene. It produces closed envelopes, wireframe envelopes for each scene. It produces all those various extent strings. It also produces thickness contours. It produces a whole posting file. So there are many things that are produced in this step. And I'll go and show you after it has completed what it looks like. It takes about, I think about 50 seconds to complete for this specific model. It's normally pretty quick. The time it takes for this step is basically a function of the complexity of the model as well as the amount of data that you use. Okay, so you can see it's completed. It took 54 seconds to do that. It produces various logs and reports that you can go and save now, and you can go view. I'm not going to view anything. So let's go and visualize the data. And okay, I'm going to select all of the wireframes, including the surface, the topo wireframe that I defined right at the beginning. You will recall I associated the wireframe with the topography. And it will take a few seconds to load. I'm working on a virtual PC here, and this virtual PC only has 2 meg RAM, so it is a bit slower than what it would normally take. You will see these tick boxes off to the side. With that, you can also select other elements for display. For instance, there's your contours. If you want to look at the roof contour of a specific scene, you can just tick one of these boxes, and then you will see the roof contours of that scene as well. At this stage, we just want to look at the wireframes of all of the scenes that we modeled, and I think it's basically loaded that now. I want to switch off the draw labels. I don't want to see my old labels. And let's load the fault wireframes as well. this is basically what it looks like. You can see it produced a wireframe for each seam. It displays them along the faults with the displacement that I defined in that fault file. It did the seam split. There's a seam split of seam B. You can see it split it into seam B1, B2, B3. This is a fairly simplistic model, but it shows the what the software does. You can see there's a reverse fault. There's actually there are 2 reverse faults there. There's also a normal fault in this model. There's a normal fault. So it can do fairly complex faulting as well. Okay, something that's new in this version, and that's something that I was hoping to get to, is you can save your visualizations differently in this version. You can see there's now a save button there. So saving visualizations is easier than what it used to be in previous versions. Okay, what we're going to do in the next step is now we're going to do the intrusive model, and I created a closed volume using this CAD tool section that we brought in with the previous version of Strat3D. That CAD tool section includes points and string and wireframe tools, similar to the tools that we have in DataMine Studio. And I use those tools to produce a closed volume that is supposed to represent my my intrusive. And I'm going to, before I model it, let me just show you what that closed envelope looks like. It's, in this case, it's a DataMine wireframe, and it's called Dykes, and I'm selecting the angle file, and now it's just asking me what's the points file. Okay, and that's basically it. It's this gray volume here is the intrusive that we're now going to incorporate into our strata model. Okay, so in order to do that, let me just unload it first. We're now going to associate that volume with a new stratum that we're going to define. And I'm going to define a new sequence. And that, get rid of that. New sequence. Okay. I want that sequence to be below my topo and above my org. And simply because this dike is going to be younger than these other seams, and it's also going to be younger than the faults. So it's going to affect my seams, but it's not going to be affected by the faults. And in order to do that, I need to make it younger, so I'm changing the geological order to C. And I'm also going to change the conformity to transgressive. And let's give it a unique name. I'm going to give it a name INT. That's the code I'm going to give it for intrusive. And just if I click on this all sequence, you can see the geological order of that is 2. So I'm giving the intrusive higher geological order because it's younger. And in that sequence, I'm going to define a new stratum, although it's not strictly speaking a stratum, it's a volume. Let's give it a different color. Let's make it yellow. And I'm going to give it a different code. We can call it DYK for Dyke. And an important step in here is now I need to associate that stratum I just defined. I need to go and associate it with a predefined volume, and that's the one I showed you earlier, the wireframe. Okay, so that's basically all we need to do to now go and incorporate this new volume into our model. Okay, so we're going to go back to the modeling step, and we're going to rerun the built drill hole model and the built wireframes. We've already done the validation of the drill holes. And this is going to take another minute, so just bear with me. While this is going on, we're already working on the next version of Strat3D, and there's some exciting enhancements that will come out in the next version of Strat3D, including some enhancements to the fault modeling to make it more like a dynamic fault editor, where you can dynamically change your fault displacement. We're bringing in more flexibility in terms of using constraints and exclusions. Yeah, I can't recall all the enhancements, but there are various areas of enhancements. An important one also that I need to mention is we are working on closer integration of these CAD tools with the rest of the workflow. At the moment, for those of you who are used to Strat3D, you will know that the CAD tools is kind of a separate mode. So we're working on making it more of an integrated approach. Okay, so it's done rebuilding that model. So let's go and quickly go and visualize it again. And this is something interesting. Okay, I'm just going to close it quickly and then reopen it. Let's go and visualize that quickly. Okay, so you'll see that it included that new sequence that we defined, the intrusive sequence, and there's the Dykes that we also defined. So let me select a few of these scenes here. I'm not going to select all of them in the interest of time. And let's load the surface again. We have about 10 minutes left. I think we will finish in time. Okay. So you will recall that the intrusive that we included, that volume was extending beyond my topography. So it's basically now cut it off against the topography. And it has also it has modeled my my seams to be without that volume of the intrusive. So the intrusive did cut out now the rest of these seam volumes, and it was as simple as that to do it. And obviously, you can do a lot more complex shapes than this, so this was a fairly simple one. That is most of the functionality I wanted to show in this project. What I want to show, and that's going to be in a different project, is the washability. So I'm quickly going to just minimize this and get a different project. And this project has a few wash samples in it. And again, it's very simple data, but it's just to illustrate the principle. So we start off with the input section. And by the way, the washability is a new module in Strat3D. Not everybody will get it automatically. It's obviously people who don't do coal modeling are not interested in washability. And that's why part of the reason why we made it a separate module. So if you don't have the license for washability, you won't see this grouping in your taskbar. You will only see it if you have the license and an active license. Okay, I'm going to re-import this file just to show you quickly the importation step. It's fairly boring, but I believe we have an edge over some of our competitors here in the sense that our import is flexible. Important is that we import fractional data, so the data has to be fractional. And part of the reason why we do it is part of the validation is done in the accumulation step. So it has to be. I think I'll just switch this around now. So yeah, I think that's correct. Okay, screen yield is it says yield, wash yield is wash yield percentage. Okay, that's enough. It's done. So in this next step, it asks us, it detects what size fractions was in the data. Not a lot of size fractions in this data set, but so there are two size fractions, and one of them is the fines fraction. So we define which one is the fines fraction. It also detects the densities in the data set, the density fractions. And okay, so oops, sorry, I picked the wrong task here. Okay, so next step is we're going to now regularize the data, and you can then select which densities you want to regularize for. This data set has to be regularized because we don't have the same densities in all of the samples. Important here is you have to define your lower limit and your upper limit. So the lower limit is where you expect to have 0% yield. So that is your density where you expect 0% yield. The upper limit is where you expect 100% yield. So the density where you expect 100% yield. You can select what coal properties you want to regularize for. So in this case, I'm not do internal moisture or volatile matter or fixed carbon. I'm just going to do it on yields, ash, and CD. And you can also add your own densities to the list if you want to have more density cut points. I'm happy with the list that's in there, so I'm just going to say regularize. And in this one, I'm going to use the linear spline. So it then goes and produces the regularized data set for each sample. If we wanted to do the cubic spline, and that is the monotone cubic spline, then you can see the lines are a little bit more curvy, and we can then go and view the results for the different samples. Okay. Okay. So once we have regularized data, the next step is to go and composite the data. And a precursor of this is you need to already have done your raw quality estimation. So we now get to the quality the goal. Sorry, the washability compositing, and we have to define which raw coal property we're going to weight it against. So in this case, we're going to weight it against RB, and in most cases, that's what you will do. So we just click the run button, and then it goes off and does the compositing. and you can go and view your composite results. Then the final step before you do your wash estimation and your product estimation is you would do your product analysis, and in this step you can do it for a primary as well as a middling product, or if you just for a primary product you can select your primary product. So in this case, let's say okay, we want to do it. Okay, let's say primary ash of 18%. Let's do ash of 25%, and then it goes off and does the product quality, the theoretical product qualities of primary product, and then of the 25%. So 25 was maybe a little bit too high. Let's make it. Let's do a different one here. Let's do it on float, and let's do 1.5. Float density of 1.5, and let's do float density of 2. Okay, so there we get a secondary product as well as a primary product, and these results are then obviously stored in the table, and you can use that to do your estimation of these products. That covers basically the scope of what I wanted to cover today, and it's just in time. I see it's just in time for the hour. As I said at the beginning, if you have any questions, please email me. I'll put my email again. I'll put my email again up, and then and if you have any questions, I'll send it to the rest of the group as well, together with the answer. So my email address, henny.coetzee@bettermindsoftware.com. Thank you very much for your time today. I'm looking forward to hearing back from you. Thank you.
Thank you.